Good evening, or good morning, or good afternoon, wherever this is. Maybe good night. Maybe you listen to this while before you go to bed, because it's just such a calming experience. In any case, I'm Isaac and this is Bruno. We're both engineers with a very strong business interest, or business people, you could also say. And as it pertains to the question of today's episode, we both have quite some experience in R&D. Actually, that's where both of us started. So the idea in this episode, which is hard limited to 10 minutes, plus, not even minus, plus 2, let's say, is how do you pursue continuous improvement in your R&D team, in your R&D endeavors? Not operations, which are manufacturing, that's a different topic, but R&D specifically, where things are not always so clear-cut as they are. So design, engineering, R&D, ambiguity, it's fluffiness that not everybody likes. So Bruno, what is a good R&D that you would strive for? How do you know that you are improving towards a certain standard? What would you say is it?
This is such a huge question, and
no.
we put these limitations on us, but we like it hard.
8 minutes. 8 minutes left.
8 minutes left. Okay. So I started as an R&D engineer in the defense industry, which usually has very long lead times. There is ambiguity. At the same time, you have very strict requirements, and there are some very high expectations. To me, good R&D process took into account end users' needs, manufacturability, maintenance over a long period of time, and now, as I'm talking, I'm realizing how I could summarize it. A good R&D results in a product or service that has the whole life cycle taken into account. So not optimized for just quick delivery, not optimized just for, let's say, cost, not optimized just for one stakeholder, but the whole life cycle. And where I found the most personal improvements and setbacks, etc., was around a lot of small menial tasks that really shouldn't have to be relearned and rediscovered again. For example, thousands of standards. So when you're when you're making defense products, it is similar to automotive industry, which has a lot of standardized components. But in this case, you have a lot of strict standards, and you need to be aware of them. You need to, as I said, thousands of them, and there is no reason to forget them again and again and again. So why cannot we make a design process that has that taken into account again, instead of relearning it between the projects, between the companies, etc.
Sounds like requirements management, though, right? So you need to know what the requirements posed on your entire product and its life cycle are before you start, to some degree at least. Maybe you don't know everything because you would then have to front load everything, but you need to start off on a solid basis, not just say, oh, halfway through we forgot that we need to also fulfill that specification or that standard, that norm, whatever. And then you have to blow up other trade-offs you've established to go back to the drawing board and pursue some other designs.
It is to an extent requirements, but it's also just the whole space of possible solutions is massive. And what I've seen, I think Durward and Sobek call that the waste of discarded knowledge in lean product and process development. There was a lot of discarded knowledge. You had different generations of engineers that I experienced both when I started, but also when I was working with different clients. And especially in Europe, there is almost, if you would turn it into a curve, it looks like a bathtub. Like a lot of senior, very experienced engineers, then a horde of us younger guys coming from universities, and then a huge blank between us. Like there's a generation missing. And there is generational difference in design philosophies, working philosophies, teaching and conveyance philosophies. It was different time. The way work was done was different. And I'll stop here for a moment because it's already 4 minutes gone.
That's good. That's good. And this is a very astute observation, I find. You have to take into account the product you're you intend to develop, or the component technology, and you have to take care of all those requirements. So everything that is the product, this intangible or tangible thing, the thing that you're developing. But then you have to zoom out and say, okay, good. I have those requirements, those aspirations. Who is going to do that and how? And then you start to find exactly those. Sometimes it's limitations. Very often it's opportunities. Usually it's limitations, my experience, because you have tension between the ones who like to develop trial and error, who, for example, were not even around, have been at it for so many years that for them simulation software is just a calculator and not an exploration tool. And you have those who come in and they reinvent the wheel because they think that they're going to show the old guys how it's done. And you have to somehow manage that. And in particular, talk to what you mentioned from the Alan Ward book, which is excellent. It's one of my favorite books. I find that the best thing, if you say you have some requirements set up and you know what is you're developing, what makes a good R&D team, like a state that I would like to develop towards, is having very fast exploration, very robust exploration, not just doing one thing, trial and error, which we had tackled in a previous episode, but being able to go from idea, hypothesis, effects, trade-offs, validation or invalidation, so that you can very quickly churn through ideas that might unlock some performance that you didn't know about, or even within the team and how people work, you might unlock a certain way of working that you didn't know could be done. For example, the way in German they call the Konstrukteur, is the guy who's doing the technical drawings in CAD, in CATIA or SolidWorks, whatever. And then you have maybe the split is functional. You have the R&D guy who's doing the simulation and the calculation, the pre-development. The way that those two people, for example, play together, that can have a massive impact on how fast the team is progressing. So it's not only the thing, it's the people who make the thing.
Absolutely. And R&D, to some extent, at least in European companies, I haven't been in so many North American, but R&D historically held and still has a very high position. It's usually the most educated people, very strong opinions, etc. So it's almost like an ivory tower. And the worst R&D processes are those that engineers stay in R&D and never leave R&D, but they design products and put them out there. I've consistently seen the best R&D things, they are on the shop floor. They are speaking with the customers. They are speaking with other parts like operations, manufacturing, maintenance. They are taking into consideration the whole process and they are actively involved with it, because that is very, very important. And you mentioned how people work together. Again, what R&D teams can do to improve their processes and output is to focus on simple things like being able to candidly discuss these ideas. It's not personal. It's not me attacking Isaac or Isaac attacking me, Bruno. We have to be able to put forward prototypes, paper ideas, whatever, and then go hard at those and discuss all these possibilities together without, basically assaulting, going ad hominem. But that is critical. If we want to explore broadly and quickly, we have to be able to discard ideas quickly. We cannot discard ideas if we are precious about them. So if I put it out there, I'm putting it out there for the team to aggressively discuss this, to see if this warrants further experimentation, exploration, or not. Then we discard it. If it's good, it's gonna pop up again. We can go back to it. But this is a small but critical improvement for any R&D team.
So it's similar to what we said in one of the previous episodes about how do you make the most out of what you have. And you could have a high performance computing cluster with I don't know how many licenses for calculating, simulating, evaluating, whatever. And if your way of working between sources of knowledge or sources of ideas is just crappy, you can keep it, like be proud of the infrastructure that you've spent hundreds of thousands on, or you spend millions on if you're a huge company, but it's just not going to make such a big difference because you are not utilizing it properly. Not in terms of, oh, I'm loading all the CPUs with calculations, or I'm evaluating how many variants every week, but in terms of, okay, you evaluate like 100 variants every week. How many of those are actually good variants? How many of those have been selected to be squeezed for insights because somebody brought in an idea and said, hey, why are we not testing this? Or, hey, I heard that this could also be important. So bringing more people together and not having such a hard functional split, I would say, is also an important part in R&D. And yeah, we talk about R&D team as if it's just a team and it's just R&D. If you have a single function, it's just a, eyes closed, we just do our thing and miraculously the product gets created. But it's actually building the team around it. So a good R&D team is embedded in a bigger team. It's not just monkeys on keyboards and mice making amazing things that they're super proud of, but without any context.
Yeah,
it's a bit of a fake question in that way. Yeah, how do you continuously improve R&D, the team? You improve the team, and how knowledge and information and assumptions flow through the team. And how do you do that? As you said, you invite people hate the word, but productive conflict, willingness to put things out there and see whether they stick or not.
Yeah.
Not empowering prima donnas. Very important in R&D. We have lots of prima donnas. PhD this, mastering that. I know everything, or I get insulted that somebody would step into my turf to tell me about, I don't know, compressor design, turbine design, my background. Nobody knows everything.
And we're just out of time.
Perfect.
Time flies. Just because we gave +2, just a small thing to add. Again, a simple thing to improve the team, but also the broader organization, is not to assume that everybody knows what you learn, because R&D includes a lot of learning. So you test a lot, you explore a lot, you have to talk about it, even to your colleagues, like simple bi-weekly social within organizational context events where you just share 3 biggest takeaways or whatever. It doesn't have to be fancy, it doesn't have to be wild, but that helps so much because it also spurs creativity, both in the individuals in the team, but also around or throughout the organization. It's like a bunch of those small things, which to me continuous improvement is about. When we think Kaizen, when we think all these concepts, it's about small improvements week by week, week by week, week by week. We are not talking about getting a new prototyping laboratory that costs 200 million euros. That's not continuous improvement.
It's tacit knowledge. It's how you turn knowledge from heads into requirements, into documentation. We'll go 1 minute longer, please. One of the craziest things I've experienced is for a project that was supposed to take 3 months. It took 1 year. Thankfully, it took 1 year because things that we didn't even know that we don't know came up in the process. And I was able back then at this company, which was excellent at R&D, to reach back to documentation of operating conditions of some equipment that was before the time I was born. And that was insightful because somebody took the care to document that. If we didn't have that, we would have forgotten quite a lot of things. And we would have found them in the process of bug fixing in the field, which is difficult when you do things that are tangible, or after sales service. So documentation, I know people don't put much value on it, but in engineering, it's key because there's too much. There's too much that you can find out and too much to keep everything in your mind. And it's not always visible. It's codified in technical drawings, in tolerances, in things that it's not like a UI in the software. It's what you see is what you get as a customer. It's much more hidden in the interfaces, in the assumptions, the temperatures, the pressures, the material hardness. For R&D in engineering, it's documentation is key. And people like to pretend that it's just the cost. Who cares about this?
We care.
We care because we've been burned by this or have benefit from it, so we care. Good. So thank you. It was a very, I think it's a very juicy topic, like most of those we pick. And I'm sure we'll revisit it in some other way, Bruno, in the future, because we have a lot of things to talk about on this. So until the next one, enjoy. Send us your comments, post below the post on LinkedIn, comment and so on. Make the algorithm happy, and tell us what else you'd like us to discuss. So until the next one, bye-bye.